And welcome to the Daily Space Weather. I'm your host Dan, aka smAsho. Looking at the closest star here in ionized iron in the wavelength of 193 angstroms. Today we'll be talking about quakes on Mars, superionic water in Uranus and Neptune, and how about some electrons as well. Here's another view of the closest star. This is a different iron UV emission spectra. It's 171 angstroms. And the colorized magnetogram, we're showing you 0 sunspots right now. Geomagnetic activity caused by coronal holes has been canceled. And here's the same view except without the colorized magnetogram. It's 171 angstroms by itself. Small active region rising in the southeast. A couple of active regions setting in the northwest. We've got a filament down in the southwest as well. Here's a close-up of that. And there is still some minor risk for coronal mass ejections right now, folks, despite there being no activity on the Earth-facing portion of the disk. Nothing really even resembling magnetic organization. Here's 304 angstroms, full disk, ionized helium. Again, there is still some possibility for coronal mass ejections. There are significant filaments around the south solar polar field region. And let's look at some more data. Here is the diagram of the solar system. I like to use the planetstoday.com. There's where things will be in a week, approaching another new moon. Here's a star chart. Speaking of the moon, it's right near the apex of its passage across the sky on the ecliptic. If you're up before dawn, you may see Saturn and Jupiter rising before the sun. The 10.7 centimeter radial flux back up to 78. Here's a 1-year chart to sort of put that in context. Although this needs to be updated, you can find it at solon.info. Yes, solon.info/solar is the location of that graph. So geomagnetic unrest and so on has been canceled, as we don't see any forecast by NOAA, or by me for that matter, for incoming coronal hole wind streams. Continuing on, let's take a moment to admire the pristine beauty of Fagradalsfjall as it continues to fill up its crater valley. Is it becoming a shield volcano? Will it become a shield volcano before our very eyes? Well, it's getting pretty hot in that valley as it's filling up with lava. Some fresh real estate being created in Iceland. Have you learned how to pronounce it yet? Fagradalsfjall. Also on the list of erupting volcanoes for the day is Suwanosejima, which exploded. Unknown volcanic ash cloud above it. Dacono exploding as well. Flight level 080. It's an 8,000 foot ash plume. Popocatépetl exploding in Mexico, 20,000 foot ash plume. Pacaya and Fuego, both exploding in Guatemala. 11,000 foot ash plume above Pacaya, 14,000 foot ash plume above Fuego. Nevado del Ruiz in Colombia, now exploding as well, 19,000 foot ash plume above it. Sangay, the Ecuadorian volcano, exploding, 19,000 foot ash plume above it. And Sabancaya in Peru, also exploding. Intermittent puffs are enough to produce a 24,000 foot ash plume, which is enough to remind our viewers to not pole vault the caldera. Now let's talk about earthquake depths real quick. One of the ways that we see earthquake depths at very strange depths such as over the ocean, where you couldn't have a negative depth because the earthquake would be occurring in the air, has to do with the geoid versus the ellipsoid, as models are used to determine earthquake depths. And the model is assuming that the Earth has basically a homogeneously shaped surface. So when you have a mountain, the earthquake could be detected in the ellipsoid, as you can see there on that image there. The red dotted line would be the ellipsoid. The estimation, the smoothed altitude, essentially. If you want to read that article, it's entitled, "What does it mean that the earthquake occurred at a depth of 0 kilometers? How can an earthquake have a negative depth? That would mean it's in the air. What's the geoid, and what does it have to do with earthquake depth?" Largest of the past 24 was a 6.5 magnitude quake here in the Kermadec Trench, northeast of New Zealand. There's a location of that quake. It happened fairly early yesterday. There was also another 6+ magnitude quake here near Fiji. That one was at depth nearly 600 kilometers. We'll get to it. The one by New Zealand, the one in the Kermadec Trench, happened at 9:56 Universal Time yesterday. And this Fijian quake happened at 11:18 Universal Time yesterday. And we're just going to continue up the list here. Indonesia saw a small deep quake at a 4.3 magnitude. Vanuatu, a 4.6 magnitude quake at 180 kilometers depth. Deep quake at Chile and Dominican Republic. Those happening about 40 minutes apart. And the most recent quake here from Petrolia, California. We've seen some anomalous depth quakes there. This one is at a more reasonable depth. There's the location of that one off of this peninsula here on the California coast. Back to some data from the GO-16. One small solar flare happened in the past couple of hours. I think that was when I was jumping out of bed. Actually, that one occurred at 6:30 Universal Time. Was the peak flux of that flare not even a B class? It was minor. No strikes on the proton flux, and no surprises there. No coronal mass ejections have been headed our way recently. Here's the GOES magnetometer over the past 3 days, and expect to see some spikiness in this coming up as the Earth is about to move into the North Pole-oriented current sheet. I'm sorry, the South Pole. The Earth is about to move from the North Pole current sheet into the South Pole current sheet. So we've got another, probably about 1 day. So tomorrow we could be in the South Pole current sheet. We could be in the North Pole current sheet. Keep in mind this data is 1 hour and 38 minutes old. It's showing you North Pole polarity in green, South Pole polarity in red. It's the heliospheric current sheet. And you're looking at this as if you're looking at the view of the sun from one of the sun's poles. Here's another view of essentially the same data. It also shows you the sun's B field in blue, which is taking its good old time for its solar polar field reversal process in cycle 25, well behind where it was during last solar cycle. Cycle 24 was much farther in its solar polar field progression process than the sun currently is. Anyway, that's the data from the line of sight coronal hole field plot. Again, the data is 1 hour and 38 minutes old. And here's just another feature from the Integrated Space Weather Analysis Center, the detected coronal holes. So we've got another coronal hole rotating into the Earth-facing zone here. And this one here that was originally expected to produce some geomagnetic unrest is quite diffuse. This one here is South Pole oriented. see it beginning to move into view here on the line of sight coronal hole field plot. Regarding Earth's geomagnetism, it's currently at a KP of 1. So the KP index, folks, is a measurement of global geomagnetism. Currently quite calm conditions over the past 3 days, as you can see there on the green bars on the graph. Next, real-time solar wind. To show you pretty uneventful solar wind, current conditions are solar wind density 5.69 protons per cubic centimeter, solar wind speed 371 kilometers per second. Basically solar minimum conditions. Here's the pressure of the geospace. It's our 4 hours of geospace magnetosphere movie. Showing you pressure, magnetohydrodynamic pressure in nanopascals. And as you can see, quite steady here according to the space weather modeling framework over the past 4 hours. Next, we'll look at the ground magnetic perturbations, coming a little closer to home here. Geospace delta B, otherwise known as changes in the Earth's B field, yes. And we'll continue on with additional data here. That refresh, we'll let that play through. We'll continue on with additional data here momentarily. It's a great moment to take a sip of your coffee. What's in your cup? Mine has organic Colombian, along with some whole milk. Yes. And let me just check the life of the stream here. Now that we've shown changes in the Earth's B field, we'll continue on to remind our viewers that this video was streamed live to Twitch. It's twitch.tv/smAsho. It's a fantastic mobile streaming platform. Thanks to our Twitch followers, thanks to our YouTube followers. Check out our other playlists and so on if you haven't done so. We make a lot more than daily space weather videos. Thanks to our BitChute subscribers. We're 1 subscriber away from 400. And let's do a cosmology segment. Should be another interesting one today. Today's cosmology segment will be talking about first cosmic rays. So here is the cosmic ray scenario, the neutron monitor at Apatity. And you can see it's flattened out here over the past 4 days. And it's flat over the past 30 days. Barentsburg, tiny uptick here over the past 30 days at Barentsburg. Next, we'll go a little farther south to Athens, Greece. There's the Athens neutron monitor. Quite flat here over the past 30 days at Athens as well. Here's Mexico City, also flat over the past 30 days. And next we'll look at Oulu, Finland. Tiny uptick over the past 30 at Oulu. DOMB, Antarctica. Tiny uptick at DOMB, Antarctica over the past 30. DOMC, Antarctica. Similar graph here to DOMB. We often see those extremely divergent from each other. Right now looking quite convergent. So there's your cosmic ray report. Next we're going to pick a random number between 1 and 1031. Today's number is 186. And I think we may have actually covered that one already. Let's pick another one. How about 42? Is it the answer to life, the universe, and everything? Well, I don't know. Let's check. 42 turns out to be SMC X1. So probably the strongest X-ray source here in the small Magellanic Cloud, the high-mass X-ray binary/massive radio source believed to be a neutron star. And you can see it's got a quite variable X-ray flux here. Here's the historic X-ray flux over the past 16 years. And quite variable there, as you can see from that graph. Here's a 30-day chart, a little more consistent over the past 30 days. Let's see if we can get a look at the SMC X1, an X-ray source, a high-mass X-ray binary located in the small Magellanic Cloud, one of the satellite galaxies of the Milky Way. And let's check it out on the Chandra. And it doesn't appear on the Chandra. Here it is on the XMM Newton, the multi-mirror project. You see some interesting loops up here showing up on the X-ray imagery. And let's take a look at it on infrared, see if it shows up on the 2 mass, and there it is on the 2 mass. Great view of that. How about pan-stars? And how about blue light? And there it is in blue light. A bit of an oblong shape to that. And we'll show it again on the XMM Newton to close out this segment. And that's just some incomplete data there from the XMM Newton, the multi-mirror project. How about some Mars quakes? 2 more 3+ magnitude quakes have been detected by Perseverance. Was it by Perseverance? I think it was by Perseverance. But in any case, the new quakes, magnitudes 3.3 and 3.1, they're all coming from the same location, folks, Cerberus Fossae. And this article is on phys.org's Astronomy and Space section. So some Mars quakes, and this may give us some insight into cosmology, folks, in that Mars is a very different planet than Earth in that it doesn't have a coherent magnetosphere. It's got just weak fields all over it. And perhaps Mars quakes can teach us something about cosmology. Here's the location where those come from. Cerberus Fossae is this sandy, this river of sand, this crack. Appears to be a zone of hot seismic activity on the red planet. Cerberus Fossae, folks. Now, interesting article here out of Japan. Very high altitude electrons. How are they generated? Well, the answer is we don't know, folks. And some of the electrons appear to be coming from the sun, and some of the electrons appear to be coming from the Earth. Ultimately, we just don't seem to know how it works. And here's a quote. smAsho says, understanding how this electric field forms will fill in gaps for understanding aurora emission and electron transport on Earth and other planets, including Jupiter and Saturn. Perhaps check out the article from SciTech Daily. I'll briefly let it scroll here for all of you folks who like to pause our videos and read the articles without ever going to them. Let's talk diamond anvils. Are you familiar with diamond anvils? Well, there's a reason why we entitled one of our playlists, The Diamond Anvil Too Hard to Smash. It's because superionized elements or superionized molecules, with respect to this article, are an emerging and super important aspect of science. The possibility that planets are made of condensed matter is super important, as these condensed matter materials have properties completely unlike what you may be expecting. Some of you may just expect water to become plasma if you apply enough pressure to it due to the heat that's caused, and that's not what happens at all. Water becomes a superionized state where the oxygen atom portion of it forms into a nucleonic cubical lattice. Now, Uranus and Neptune are believed to have some superionized water in them, and that could be an explanation of why their planetary magnetic fields behave as they do. So perhaps check out this article. Here's a great diagram of how offset Uranus and Neptune's axial tilts versus their rotations are. You can see how far off. And notice how their rotational angle versus their axial tilt are at similar angles with respect to each other, 59 degrees and 47 degrees off axis, while the Earth is only 12 degrees off of its axis. In terms of its angle with respect to the ecliptic, which is the plane on which planets orbit the sun. So there you go. There's a great diagram of that. And this could explain some stuff about Uranus and Neptune and their strange magnetic fields. This article from phys.org, you may find this one all over the Science Wire Once again, I'll let the whole article scroll in case you'd like to pause the video and read it. And again, that's on phys.org's Astronomy and Space section, and that's today's cosmology segment. We hope you enjoyed it, and if you did, don't forget to press like and subscribe, as nobody knows about our channel. So please perhaps consider pressing share and sharing on your social media. Tell your friends, foes, science noobs, and science pros about the channel, and if you know an influencer, tell them to drop us a line. Perhaps we'll feature their channel as well, if they'd be so kind as to feature ours. And let's get back to some data about electrons. There's a 1-year chart of the greater than 2 mega electron volt electron flux reported by Solon.info. Here's a 3-day chart. Nothing too exciting going on when it comes to electrons. And here's the forecast model. The green boxes are the forecast and the yellow diamonds are the observation. Here's a diagram of the Earth's Van Allen belts and altitudes in miles. And here's a visualization of the total electron content. So this is the whole air column, folks, showing you the location of electron density within the Van Allen belts. Your GPS satellite must communicate through all of those electrons, which can cause errors. And this visualization here will show you where errors are most likely to occur, which is typically around the equator at noon. So you'll see a little bit more in a summertime noon equatorial region than a wintertime noon equatorial region. It all has to do with the location of the sun overhead, basically. Here's a diagram of the atmosphere. It shows you things like the troposphere, where all your weather occurs, the penetration of electromagnetic radiation, into which layer it's mostly adsorbed, dissipated, however you'd like to say it. And it also shows you this red F over here, which is the F ionosphere layer, which readies our viewers for the next pane, which is a visualization. Don't be a pain. Understand the vibration going on above your head right now. Here's a map of the ionosphere. It's showing you the vibrational frequency of approximately 300 kilometers of altitude, where there are lots of ions bouncing around. And we see some anomalies once again here over the South Pacific. So some sudden charge ups and charge downs over the South Pacific. This particular data set is Australia Bureau of Meteorology. Some anomalies here in the ionosphere. Some charge ups ahead of the sun, some charge downs on the nighttime portion. Here's the latest image. Keep in mind the resolution's only 1 megahertz, folks. In other words, millions of vibrations per second. There is the current image from 9 o'clock Universal Time. Let's do some meteorology and check out this powerful low pressure system over the North Atlantic. It was translating all the way to the jet stream yesterday, and indeed it still is today. So anyway, there are the jet streams of the Western world, which are all over the place. We've got some extremely cold air being forced down into places like Bermuda, it looks like. We've got an area of jet stream stagnation happening right there. Oh my God, it's the Bermuda Triangle. Did you know the Great Lakes Triangle is statistically much more dangerous than the Bermuda Triangle? Yes. It all has to do with narrow inlets and sudden pressure changes over the Great Lakes Triangle. Narrow inlets focus high seas. And we're not talking about the beverage. Here are the jet streams of the eastern world. I would note they're blowing backwards over the central Indian Ocean. And here are surface winds of the eastern world. Next, looking at pressure maps. And we're going to show you a temperature anomaly map next. Here's the pressure maps for the GFS forecast. There's where we expect pressure to be at 1 p.m. Eastern Time tomorrow. And check out the high pressure over northern Greenland. Some extreme high pressure up there. Looks like an anticyclone. An anticyclone, folks. They rotate clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. And it looks like we're going to get some warm weather in April. So some temperature anomalies coming in April. This is a Zero Hedge article. And reporting on some above average temperature, finally. So hoping some planting will get done early. And here is the Tropical Tidbits temperature anomaly forecast. We'll move this ahead. Here's where the GFS forecast puts a temperature anomaly tomorrow, and we're still seeing very cold temperatures over the southeastern U.S. especially. Most of the eastern U.S. actually, and those purple areas are like 12 degrees Celsius below normal. There is that extremely high temperature zone. You're looking at like 20 degrees Celsius above normal here in North and South Dakota. That is for the 4th of April. You can see most of the north central U.S. here forecasted by the GFS forecast to remain in quite high temperatures there. So we may see some rapid melting here as we see sustained high temperatures forecasted by the GFS. That's from Tropical Tidbits, by the way. Next, a real-time lightning map. I like to use lightningmaps.org. Anyway, there's our global real-time lightning map. Some lightning there over Central America. Next, a U.S. Doppler radar. And snow continues to fall. In fact, it may be snowing outside right now. And if you're wondering where we're located right about there in Lehigh Valley, Pennsylvania. Shout out to Smash staff. Did you make smashamash.com/ambihost yet? Smash staff, everybody. Leave a comment for Smash staff. Tell her you appreciate all her hard work. And you'd like to give her a raise by becoming a patron or picking up some merch. Check out the low clouds over the Gulf. Some anomalous looking low clouds there. Are they caused by cosmic ray flux? Here's a water vapor map. And there's the cloud layer once again. And there's the water vapor once again. And you can see this cold air coming from Canada is what's making the eastern portion of the U.S. so cold. It all has to do with it being deflected off of the jet stream and sent to the east by this dry mass of air. Two different systems of dry mass of air here over eastern Texas. And Oklahoma should see some interesting cloud formations today. At least over the next few hours. And I'm just going to zoom in on the Gulf of Mexico here for once. I'm going to zoom in on southern Louisiana to show you the interesting cloud formations. So they won't show up in the water vapor map because they're very diffuse low-altitude clouds. But here they are on the shortwave radiation map, 3.9 nanometers. Some anomalous clouds there. And once again, we've actually got two systems. You can see even lower altitude clouds below these. So two different systems there. And it all has to do with essentially a temperature inversion in that area. Next, we'll look at some hydrogen alpha as we get into bonus features. And let me just check the life of the stream here. Everything looks just fine. Here are some bonus features, folks. It's the latest imagery from El Teide, Spain, in hydrogen alpha, 6,562.8 angstroms. And you can see some of the filaments down here in the southern hemisphere, folks, as well as this one that we showed you earlier in the video, in 171 angstroms. Looks like some clouds must be over El Teide, Spain right now. I would also welcome our viewers to the Neo Renaissance and invite you all to check out our own website. You can find our social media links and so on, as well as links to our merch. If you click on smAsho merch, you'll find our next featured product. By the way, if you'd like to win a free month of Patreon, somebody's getting a free month of Patreon in May. Just enter our slam poetry contest. It's free. Today's featured product is the Do Not Pole Vault the Caldera mug. So we would remind our viewers not to pole vault the caldera. There's a mug to tell your friends and foes about it. Do not pole vault the caldera, folks. And thanks to our patrons. Please consider becoming one at patreon.com/smashomash. Our success is our Patreon success. As the more capabilities we get, the more benefits we roll back to our patrons. Patreon.com/smashomash for the earliest alerts in the world. Thanks, Smash Team, for tuning in. Here come bonus features in the form of the high-res magnetogram and the high-res solar intensitygram. So first of all, the magnetogram is going to show you 0 sunspots. There is an active region rising down here. It is not yet classifiable as a sunspot, if it even is one, and I wouldn't make a bet on that. There's a close-up of it. Here's a close-up of the magnetic fields. Too early to really call. And we'll close things out here with close-ups of the setting former sunspot regions of 2811 and 2812. Now decayed to plage. Great views of their magnetic loops. And last but not least, we'll show you the active region rising. Thanks for tuning in, folks. Remember, stare at the sun. Attempt to understand the physics. Don't drink it. If you do, don't drive. Seriously, don't drive. What are you doing this weekend? Leave us a comment. Let us know. And since it'll never be now again, welcome to the Neo-Renaissance, folks. May that solar wind be at your back.